Discovery of proton. In 1886, Goldstein observed that in addition to cathode rays, other rays were also present in the discharge tube. These rays were traveling in opposite direction to cathode rays. He used a discharge tube having perforated cathode as shown in figure. He found that these rays passed through holes present in cathode and produced a glow on the walls of discharge tube. He called these rays are canal rays. The properties of these rays are as follows. These rays travel in straight line in a direction opposite to the cathode rays. Their deflection in high and magnetic field prove that these are positively charged. The nature of cathode rays depend upon the nature of gas present in discharge tube. The rays do not originate from the anode. In fact, these rays are produced when the anode rays or electron collides with the residential gas molecule present in the discharge tube and ionize them as follows. M plus E raised to power negative give us M positive plus 2 electron negative. Mass of these particles was found equal to that of a proton or simple multiple of it. The mass of a proton is 1840 times more than that of electron. Thus, these rays are made up of positively charged particles. The mass of charge of these particles depend upon the nature of the gas in the discharge tube. Hence, different gases produce different types of positive rays having particles of different masses and different charges. Keep in mind that positive particle produced by a gas will be of the same type. Positive rays produced by the lightest gas hydrogen contain protons. Discovery of neutron. Rutherford observed that atomic mass of element could not be explained on the basis of the masses of electron and proton only. He predicted in 1920 that some scientists were in search of such a neutral particle. Equivalently, in 1932, Chadwick discovered neutron when he bombarded alpha particle on a beryllium target. He observed that highest penetrating radiation were produced. The radiation were called neutron. Properties of neutron are as following. Neutrons carry no charge. They are neutral. They are highly penetrating. Mass of these particles were nearly equal to the mass of proton. Rutherford atomic model. Rutherford performed gold foil experiment to understand how navigate and positive charge could coexist in atom. He bombarded alpha particle on a 0.004 centimeter thick gold foil. Alpha particles are emitted by radioactivity elements like radium and polonium. These are actually helium nuclei. They can penetrate through matter to some extent. He observed the effect of alpha particle on a photographic plate on a screen coated with zinc sulfide as shown in figure. He proved that the plum budding model of the atom was not correct. Observation made by Rutherford were as following. Almost all the particles passed through the foil undeflected. Out of 20,000 particles, only a few were deflected a fairly large angle and very few bounced back on hitting the gold foil. Resulting of the experiment. Keeping in view the experiment, Rutherford proposed pel- planetary model for an atom are concluded follows result. Since most of the since most of the particle pass through the foil undeflected through most of the volume copied by atom is empty. The deflection of few particles prove that there is a center of positive charges in an atom, which is called nucleus of an atom. The complete rebounds of a few particles shows that nucleus is very dense and hard. Since a few particles were deflected, it shows that the size of nucleus is very small as compared to the total volume of an atom. The electron revolve around the nucleus. An atom as a whole is neutral, therefore the number of electrons in an atom is equal to the number of protons. Expect element all the other fundamental particles that lie within the nucleus are known as nucleus.